Hey guys, so today we are going to talk about limits. So let's get into it. Now, I'm not going to talk to you about your personal limits or my personal limits. I'm going to talk to you about limits in the context of a project, basically. For this to make some type of sense, I have to give you a slight bit of context, but bear with me. So the other day I had this discussion with one of my colleagues. He is a functional programming advocate and he is immensely talented and he's a genius basically. And we were talking back and forth about these functional concepts basically, such as monads and pure functions and all that great stuff. And we were discussing about the project that I'm working on at my job basically, where we have a slight hybrid type of situation. We're working in Scala, where we are more on the object-oriented spectrum of, one side being 100% functional and one side being 100% object-oriented. And so we basically have a service-oriented type of architecture. And this is a fairly standard architecture. A lot of people who come from Java will probably know what I'm talking about when I say that, we have our controller and then we have a service or several services that handles the incoming request, email service, product service, yada, 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 yada. Now, so the discussion between me and my colleague kind of went back and forth between, is this a good approach? Could we improve this? Could we try to make things more functional and maybe use more of these good practices that functional programming is bringing to the table? And so I explained to my colleague my take on these matters, and I said, well, I think absolutely we can, but I think that our focus should be we should maintain the service-oriented architecture, but I think what we should focus, instead of trying to rewrite this, we should try to extract all the impurities from the service, so that the service method call, such as say send out email or so forth, simply takes in all the data that it needs in order to do its job, and any type of impure function that it needs to do or use in its execution. So if you actually have an impure network call or something like that, you simply pass that in as a dependency, because the goal or the end result is going to be that you're left with a service that takes in everything it needs in order to execute its logic, which is very testable and it's very maintainable. And so we talked, and my colleague finally said, but Fredrik, don't you want to take it one step further? Because we could make it so much nicer. We could remove this service and we could start using composition, like functional composition, and create a pipeline and all that stuff. And he was even talking a little bit about a monad here and there. And I said, I think that if we do that, we will actually do more harm than good. There, I said it. We will do more harm than good. And he kind of asked me, okay, well, could you elaborate a little bit? And I said, well, you see, the problem is that although you and me are very passionate about good practices, and not necessarily good practices just because it's functional doesn't make it good, and we have all these discussions and all this interest, and we have all of this passion for what we do, and we want to produce good, strong solutions. But what is a good, strong solution? Because at the end of the day, it's very rare that there's a technical problem with solving something. Because if you think about it, our discussion here is not about the code being bad. We are not really... the discussion is not even on the spectrum of the code being bad. It's actually just us talking about how we could improve something that is already kind of working. And if we then start moving this over to an implementation that is much more complicated or something that we like but is breaking the consistency in the rest of the project, that's actually not a great thing. So we really have to have a good reason for deviating from an established practice, even if the practice isn't the perfect one. And why is that important? Well, I'm glad you asked. You see, that's important because the limit or the thing that decides what a good refactor or a good implementation or a good improvement to the code actually is not necessarily the technical solution itself, but rather how maintainable this solution is going to be over time. And the thing that determines if something is maintainable over time is how much time you are going to save for everybody, not just you, everybody. And my colleague kind of said, yeah, I kind of suppose that I see your point, but don't you think that this would be an okay thing to do with our colleagues? And I said, yeah, absolutely. We could, if we did this, we could make a political move, we could educate everybody, and we could do all these things, but you have to weigh the benefit of doing that against the end result. In other words, do you think that, because there's a sweet spot to these things, if we do what I'm suggesting, which is basically maintaining the interfaces and simply extracting out the values and the logic outside and passing them in, that's very low effort for us, and it will give us a lot of productivity when we write our tests, because now we cut down the amount of total boilerplate we have to produce for every single test, and it's going to overall save us a lot of time. But the concept is still as easy as it can get. You don't need to be a functional nerd. You don't have to know about monads. You don't have to know all of these things. And at the end of the day, the limit for what type of software you can write is not the guru or the super evangelist, it's the salary programmer. And he said, what do you mean, the salary programmer? You see, the salary programmer is the person who is here to do a job. That person loves his or her job, but they are not necessarily the people who are reading up on all the best practices, all the magazines and all that stuff. But they are still a valid part of this company, which means it's kind of like a football team. Even the weakest player has a spot on the team. Therefore, this team or a good coach needs to account for that person. Now, sure, you can argue that you should just have the best of the best players all the time, but that's not realistic. You have to think about the team as a whole. You can't just think about the people who are in the very top range of everything, because these people are not the whole team. And even though you could, in theory, set things up so that the solution would produce all this value, the people who implement it may be in a situation where they now have to make sure that everybody else understands. And what's even worse is if they leave the company and they have some super fancy, awesome implementation that only they really understand, that knowledge is gone when they quit. And nothing, guys, trust me on this, nothing gets unmaintainable or creates tech debt as quickly as some genius programmer creating a super fancy, awesome solution in a style that they are accustomed to, basically breaking the established pattern, and having them basically own, because what very naturally happens is that they get to own that piece of the code because nobody else feels comfortable working with it, and therefore the knowledge of how that works is isolated into that programmer or that group of programmers, and as soon as they leave or somebody else needs to touch it, there's a lot of problems. So what I'm telling you is that although some patterns, such as service-oriented structure, service-structured or service-oriented, whatever you want to call it, that paradigm, it may not be the sexiest thing in the world, but it's one of the simplest ways for you to write scalable software. And what I told my colleague was basically this: that's the core issue. I see a lot of these innovative, modern, trendy, especially in the younger programmers, they want to push for all these best practices and all of that stuff, but they don't realize that good software is not written with super advanced, super effective code all the time. Really good software is usually the sort of software that is as simple as it can get while doing what it's supposed to be doing. That's actually closer to the truth than anything I've ever seen. Like, there is absolutely situations where you need to write really advanced, fancy software, but that perspective you need to put that in perspective. You have to have the sort of problem that warrants a super fancy solution, because if you create a solution that is super fancy for every single problem, you're actually going to you're just going to create another sort of problem. So you need to be sure that if you want to do this super fancy thing, that it's warranted, that it's a good fit for the problem. And then you put in all the work of educating everybody and getting everybody up to speed. Or otherwise you have to work in a team of people who are super geniuses just as you. That's what you're going to have to do, because a chain is only as strong as its weakest link. And unfortunately, it's very difficult to create a chain where every single piece of the chain is exactly as strong. It's just not feasible. So as we talked, and he kind of understood my point, and I'm very happy to say that this discussion we had led to a very nice compromise. So we keep the simplicity of an established way of working that all of our colleagues, both the ones who are really, really enthusiastic and study and like really, really keep themselves relevant, and the colleagues that are there to just do a good job and still have families and all that. So both parties are happy, and we create a nice improvement to the code base that reduces the amount of boilerplate that affects absolutely everybody when we're writing tests. And so we get 80% of the benefit without all the issues that come with creating a fancy solution that would solve 100% of the problems for that one case, but may also create a lot of other problems in other areas. So I hope this was useful to you. Have a great day.